Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. And today we are going to do indefinite integration by parts. But before starting, let me check my voice, audio and video whether I'm live or not. Alright, so alright, so let me check my audio first. Yeah, it seems alright. Alright, so I'll start with my introduction. I'm Jeetendra Dixit. I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years to excel in mathematics. Alright, so in this session we are going to do integration by parts. Today we'll start basics of that and we'll continue it tomorrow as well. So tomorrow we'll cover some special forms which I've done through integration by parts. So that will be a challenging session tomorrow. But today, as I told you, we are starting it, so we'll do the basic things, basic problems to understand this topic better. Alright, so let's start it. But before doing so, let me also tell you about the Unacademy Subscription. So as you know, Unacademy is India's largest online learning platform and you can prepare for any exam on this platform. So let us talk about IIT-JEE. If you want to prepare for IIT-JEE and want to take subscription, then after taking subscription you get daily live classes of all the JEE educators. All the JEE educators means you can access any educator, that is up to you. So you can choose a set of set of educators or a particular course going on the platform. It is up to you. You can watch them live lectures, all the live lectures which are pre-planned, everything is scheduled, so you get to know the information of all the upcoming exams. And during the live sessions you can interact with your educator through chat and you can send your doubts as well. There are dedicated doubt sessions as well, so you can attend those doubt sessions. And also you can watch the recorded lectures, so whatever is taught today, that is recorded also on the platform, so that you can download and watch it offline as well, right? So if you miss something, then you can watch it later. Live tests and quizzes are also available, so that will be free. After getting the subscription, you can appear for as many quizzes as you want. You can attend all the All India test series going on the platform, so which is very important part of your preparation. All these courses are well structured. As I told you, everything is pre-planned, so you get to know the information of all the upcoming exams, all the upcoming lectures in advance. Alright. You can download this Unacademy's learning app from Play Store, and after downloading this, you can subscribe for 1 month, 3 months, 6, 12 and 24 months. Alright. And after getting the subscription, you can subscribe for 12 and 24 months. These are the best packages, as you can see. Compare it with the prices above for 6, 3 and 1 month, and you'll find, of course, the better, right? These two packages are better than any other in terms of per month average price. Alright. So if you are in 11th or 12th, you can choose these 2 years, and 2 years is the extremely low. But let me give you one more information. These prices are increasing from 10th of September. So guys, hurry up. If you haven't taken the subscription, then take it now. Alright, this is the new price list which is out and it will be applicable from 10th of September. So you can compare the prices. This 27,000, which is after 10% discount, is going to be 34,650. That too after 10% discount. Alright, and this 2 years price is going to be 50,400. Alright, so hurry up. If you haven't taken the subscription, then take it now. It's always advisable to buy these packages, alright, with this price. You can use my code JEET1 to get instant 10% discount. So yes, you can do that. You can use my code and get 10% instant discount. Alright. So this was about the subscription, and now let's start the topic by parts. Okay, so I'll tell you the formula. Whenever two functions are in product, then how to apply this formula integration by parts. Alright. 1 minute, guys. can see whenever you have two terms in product like this, integral of fx into gx, or you can write f into g into dx, alright? So you need to choose one function as first and second other function as second function, alright? First and second. So I'll call it first function, second function. So f I'm calling the first function and g I'm calling the second function. The general rule is which function you can integrate easily, you can choose that function as second function, and which can vanish, or suppose x raised to n is there, so after differentiating power reduces, right? If x is there, so after differentiating it will vanish, right? So such functions, differentiating, you can differentiate any function actually, that is not a problem. But after differentiation, if expression becomes easier to solve, easy to integrate, then that function will be that function should be differentiated in this method. There is one rule also which is called IIT. So in this order you can choose your first and second. So which function appears first, you choose that function as first function, and which appears later, in this order you can choose first or second, alright? So which will come before the other, that will be the first function, and the other function which is followed by the first will be the second function. What is this IIT? IIT represents, I represents inverse functions, L means logarithmic functions, E means algebraic functions, T means trigonometric, and E means exponential functions, right? So these are all types of functions. So suppose if you have inverse function and algebraic function in product, say inverse and algebraic, say x into sine inverse, something like this, then this inverse will be your first function and this will be your second function. So I hope it is good. You're getting it, all right? So this will be the order. By this rule you can choose. But sometimes you might have only trigonometric into trigonometric. Then what will you do? Like suppose it is sine x into sec square x, right? Then in that case you'll have to decide which function you can integrate easily and which to differentiate. And after integrating and differentiating whatever function you're getting, their product should be integrable, okay? I'll tell you the formula and then you'll come to know why I'm saying this. So formula of this is first function as it is, first function, I'm writing this first, into integral of second, alright? First means f and second means g, alright? So first into integral of second minus integration of differentiation of first with respect to x, alright? Differentiation of first into integration of second, which you have done earlier also, and integration of product of these two, alright? You need to integrate again, okay, in the second term. So in second term, you can see in this term, you are differentiating first term, integrating first term, second term, sorry. So differentiation of derivative of first and antiderivative of second will be multiplied together and they will be integrated. That product will be integrated again, alright, in second term. So that is the formula. If I write in terms of f and g, then it is f, alright, into integral of g x dx minus differentiation of first, so that is f dash x, if I write derivative of f as f dash, and integral of gx dx, alright, as it is, and whole integration of this product, alright. So this is the formula. This you need to apply as integration by parts. We'll practice this formula first so that we'll get familiar with this formula, and then we can start solving the problems, okay, practice problems. So let me tell you one example. This is integration of x tan inverse x. So as I was telling you that when you have one function as algebraic function, this integral of x tan inverse x dx, this is your algebraic function and this is your inverse function. So you know IIT, you call it IIT rule. So in this inverse is first function, so this will be your first function, obviously, right? And algebraic is the third function, so this will be your second one in this method, okay? So this way we can choose our first and second function, and after choosing it, now apply the formula. So after if you apply the formula, it will be first function, that is x, into first function is your tan inverse. Alright, so let's apply this. First function is tan inverse, so tan inverse x into integration of x. Although now differentiation of x will vanish, but if I choose x as first function and tan inverse as second, then I don't know the integration of tan inverse. Alright, so I will stuck there. That's why there's no chance. You need to integrate x only. So it is x squared by 2. Alright, so this is the first part minus. In second part, you need to integrate integration of differentiation of first. So differentiation of tan inverse, that is 1 upon 1 plus x square. I'm directly writing the derivative of tan inverse. This is differentiation of first function into integration of second, which I have already got x squared by 2. You have already written it here, right? So I'm just copying the same thing here. And integration of product of these two derivatives and antiderivative of f and g, first and second. Alright. So this is another version of integration. This you need to do. Let's do that. First write x squared by 2 into tan inverse x. This is done. Okay. We don't need to do anything in this. So this is your first term minus 1 by 2 of integral of, now it is x square upon 1 plus x square. So some manipulation is required in this. You know how to do it. We have already done such problems. So just add plus 1 and minus 1 and divide it separately, right? Then you can integrate. So first term as it is minus 1 by 2 of, if I divide it separately, let me put the brackets first. So it will be integration of 1 dx minus integral of 1 upon 1 plus x square dx. Okay, this is going to happen. And let's write the final answer. Okay, so I'll copy everything, I'll write everything, whatever we are getting. So first term which we are getting was x square by 2 into tan inverse x, alright, minus 1 by 2 of, now opening this bracket and integrating simultaneously. So minus 1 by 2, integration of 1 is x, then next term will be plus 1 by 2 of, integration of 1 upon 1 plus x square, you know, is tan inverse, right? So that will be tan inverse of x. And then finally put 1 integrating constant c. No need to put integrating constant here and here. The integrations you were doing in between the process, okay? The second integration. I mean the first integration actually. Alright, no need to put integrating constant. So finally in the end you can put this arbitrary constant, alright? Once you are done with both the terms, first and second. So this is the arbitrary constant you are putting in the end. Alright, so I hope you understood this formula. Let's continue. Second example. So this is our second example, okay? X ln 1 plus x. So let's do it. So we need to integrate in this x ln 1 plus x. So which function is your first function? Just think about it. Think about it. We have this IIT-JEE. See this order and see this order and figure out which is your first function and which one is your second function. So I hope you have got it right. So this log is your first function. You need to differentiate it. Obviously you can't integrate log 1 plus x. And this is your second function. Alright. So let's do it. First function ln of 1 plus x into integral of x, that is x squared by 2 again, minus differentiation of ln 1 plus x, so that is 1 upon 1 plus x, alright, into integration of x, that is x square by 2, so x square by 2, alright. So in this way we can write the first step, and after this part is already done, so let's write it again, x square by 2 ln of 1 plus x minus 1 by 2. Now some manipulation is required. This is x square upon 1 plus x, alright. So like we have done in the previous problem, in this problem also that kind of manipulation is required, I mean partial fractions. So if you subtract minus 1 or add plus 1, you can factorize x square minus 1 as x minus 1 and x plus 1, then you can divide by x plus 1, alright. So finally if I write it here only, it will be x square by 2 ln of 1 plus x as it is minus 1 by 2. Now let me put the bracket. So first term will be, if you divide this x square minus 1 by x plus 1, so only x minus 1 will be remaining, right? And then you numerator dx plus integral of 1 upon 1 plus x as second term, alright. Now let's do it, let's finish it. Now we know the integration. So final answer, if I take this is equal to I, so I is equal to, alright, I is equal to first term as it is, that is x square ln of 1 plus x by 2, alright, and minus 1 by 2 of, now integral of x minus 1 is x minus 1 the whole square by 2, alright, plus integral of 1 upon 1 plus x, that is ln of 1 plus x, alright, plus c. So I hope it is clear, right? You can integrate this separately also, like x square by 2 and minus x, alright? That is also alright. So some constant will get plus 1 by 2, that will go with the arbitrary constant, or you can write like this also, right? So both are correct. I mean, you can open this and take the constant with the arbitrary constant, okay? So 1 by 2 you are getting inside the brackets, and after that multiplying by minus 1 by 2, it will be minus 1 by 4. So you can separate that according as the what is the option, what kind of answer is given in the option, accordingly you can manipulate it, alright? So this was the integration. Let's do the another one. Yeah. So e raised to ax and sine bx. It is of this type actually. E raised to ax. It's a famous one. E raised to x sine bx or cos bx dx. So very, popular integration which we do using integration by parts. So you can do in terms of a and b, or you can do in terms of 2 and 3 by taking a and b as 2 and 3. It doesn't matter. If you're doing it in terms of a and b, you'll get answer in terms of a and b, and later you can put a is equal to 2 and b is equal to 3, alright? So I'm doing it in terms of a and b, and then later we'll put a is equal to 2 and b is equal to 3, right? Where a is equal to 2 in this question. In this question, a is equal to 2 and b is equal to 3 for this particular question, right? Alright, so let's start this. 1 minute, guys. Let me check my voice once again, if it is still proper or any echo or something. So I think a slight, let me remove this now, let me check. I think it's better now, right? Hello? Yeah. Alright, so I'll continue with this. Alright. Okay, so let's do it. Let's do this integration. Hi guys. So let me do this. 1 minute. So which function is actually, you can see in this rule ILATE, ILATE. These two functions are the last two functions, trigonometric and exponential. So in any function you can choose as first function or the other one as second. It hardly matters. But let's do it in the order which is given. So this will be our first function because trigonometric is coming before the exponential. Exponential will always be the second function, will always, okay? That means we'll always going to integrate the exponential function. Whenever you have an exponential function in the question, always take its second one, right? Okay, so now let's apply the formula. After applying the formula, you'll get sine bx first function, sine bx into integration of second, that is e raised to x ax divided by a, minus integral of differentiation of sine bx, that is b cos bx, all right, integral of e raised to ax, that is e raised to ax divided by a, all right, dx. But we are again stuck. We have again got the same kind of problem, cos into e raised to x. We can't integrate this. It is similar to e raised to ax sine bx, right? That means at this step you need to apply by parts again, okay? And let's see what will happen if we apply the by parts again. So it is 1 by a sine bx into e raised to ax minus, let's keep it outside, b upon a, and apply the by parts in this integral of cos of bx and e raised to ax. I'm writing this, and then next step I'll apply the by parts, all right? So 1 by a sine bx e raised to ax minus, now let's apply the by parts. So which will be our first function? As I told you earlier, it's like e raised to ax is always the second function. So cos bx, okay, cos bx into integral of e raised to ax is e raised to ax divided by a minus integral of, all right, integral of differentiation of cos bx. So it is sine bx into b. I'm writing b and with negative sign also. So I'm putting plus sign in between. And e raised to ax. So it will be e raised to ax divided by a. And let's write this a outside, okay? Dx. Now you can see this function is same as the original question. This is nothing but the I, right? So I'll write it I and I'll get this relation. I is equal to 1 upon a sine bx e raised to ax. Multiply this b by a inside. Now we have got the integration. So minus b upon it will be a square. All right. Cos bx e raised to ax and minus b square upon a square into I. All right. Now let's separate this. So it is I plus 1 plus b square upon a square, all right, is equal to I, let's separate it. I'm separating this I, okay? I'm club this b square upon a square I, or take it to left hand side. So we'll separate I, all right? No need to integrate it again because this is the same question. So we are separating it and write the rest of the terms on right hand side. So it will be, again, take a square LCM. So it will be LCM is a square. So a square, it is like this, a sine bx e raised to ax, all right, minus cos bx e raised to ax, which you can take common later. So I'm writing it here and then I'll take common, all right. So finally, okay, into b also, into b, all right. So finally, if you take LCM here also, so a square will get cancelled and I is equal to, will get a square plus b square is in product. So take that right hand side in the denominator. So b square plus a square or a square plus b square. Take e raised to ax common and it will be sine bx a into sine bx minus b into cos bx. All right. So that is your final answer. Now you can put a is equal to 2 and b is equal to 3. So that is one particular example of this particular type. All right. You can put a is equal to anything or b is equal to any other number. So this was the, you need to do this integration twice. Sine will always keep changing into sine cos. E raised to ax will remain same. So after doing it two times, first sine will change to cos and then in second times it will change to sine again. And then same question will be framed again. So you can keep that is equal to I and you can separate it, and after separating it, you'll get your answer I. All right. So that process you must have done somewhere in class 10th in some type of questions, right? When a series is given, a pattern is given, which is going to infinite number of times, you take that expression as I and then again replace that I inside, right? That expression. So that kind of thing is okay. All right, so let's move to another example. Okay, let's start the questions. Okay, let's do this a practice session. So this is the first problem. Try this particular sum. I'll discuss this after a minute. All right. So this is exponential and algebraic form. So what are you doing? Which one is your first function and which one is second? Have you selected? Okay, I'm waiting for a minute and then I'll discuss. Keep trying. Sometimes before if starting by parts, you need to simplify it also. It's a hint. Do not directly jump into by parts. Oh, this is algebraic into exponential. Okay, let's just start by parts. You can do that, but simplifying is better actually. Simplifying will make your life easier. So what is there to simplify in this? You can put x square is equal to t, right? It will be simple. See, this one is extremely easy integration. In fact, this you can do it in your mind. X e raised to x, x e raised to x. The first function is x. Always exponential is the last second function. So integration of e raised to is e raised to x minus differentiation of x is 1 and integration will remain same e raised to x. And again by putting second times integration it will remain e raised to x. So finally you're getting x e raised to x minus e raised to x. So that's what I was saying. This is extremely easy integration. X e raised to x is e raised to x x minus 1. You can remember like this. E raised to x into x minus 1 plus c, right? I mean, you can do this in your mind. So how to use it? I mean, what is the use of this here? You have integration of x cube, right? Are you figuring it out? What is the answer? E raised to x squared dx. You can compare it, you can do it in two types, either by substitution or without using substitution. You just need to multiply and divide by 2. So you can write this integral of, just separate 1x square and write 2x e raised to x square, alright? So now this is your e raised to x only because you have e raised to fx into f dash x, alright? So if you apply by parts, it will be 1 by 2 of x square as it is into integral of this f dash x e raised to fx is e raised to fx, right? So e raised to x square minus, now it will be integral of differentiation of first, which is 2x, right? So you can see 2x will be the integral differentiation of this, and e raised to x square will be e raised to x square. Integral of, I mean, this is e raised to x square. Again, you have got this f dash into e raised to f, right? So you can directly write the answer of this. This will be 1 by 2 of x square e raised to x square minus e raised to x square, right? Plus c. Or what you can do if you are not comfortable with that, because we have practiced it earlier also, f dash into f of gx into g dash x to write it directly. Or you can put x square is equal to t first of all, and by putting x square is equal to t, you can write 2x dx is equal to dt. Follow these steps. So you can see that 1x will go with dx. So that can be written as dt by 2. So 1 by 2 is outside and dt. And it will be e raised to t into t. Now you know the integration of t e raised to t. It is written here, right? I have written it here only, right? So t e raised to t is simple. E raised to t, t minus 1, all right? Plus c. Now put the value of t because we have done this integration. So just put the value of t, resubstitute. So e raised to x square minus 1. And we are done. So you're getting the same answer. This is same as this, all right? Both are same. So either way, you try it. Both are correct. Pretty simple. Now let's try this one. See how to do it. Try it. These questions are very simple. We are just applying these formula of u into v by parts. Just get comfortable with this. So which function to integrate and which function to differentiate? Sometimes it is easier to figure it out because if you know the integration of some particular function, like in this, you obviously you know the integration of x. You also know the integration of x into tan, that is sec x into tan x, that is sec x, right? So you can integrate that also. And in the order I, L, A, T, E. T is the second function. Algebraic is before trigonometric. So that means your X is going to be different. I, L, A, T, E. So this is going to be a first function, algebraic, or you need to always integrate trigonometric, all right? Because in trigonometric integrations, it never vanishes, all right? It either changes sine to cos or cos to sine or sec square to tan or tan to some other function, complicated log of something, right? So if you integrate sec into tan, then log is not there. It will remain an integration trigonometric function, which is sec, right? Integration of sec into tan. All right, so let's start it. X into, we'll separate this sec x into tan x dx. So this will be your second function, all right? And this will be your first function. So first function x into integral of sec into tan. I'm directly writing integral of sec into tan is sec x, right? So sec x minus integration of differentiation of first. So differentiation of x is 1, right? And integration of sec into tan is again sec x. So I'm directly writing the derivative and antiderivative, all right, of these two functions respectively. So I have got to this step. Then finally I'll write x into sec x minus integral of sec. So what is the formula of integral of sec x? That is ln of sec x plus tan x. All right. So integral of sec x is ln of sec x plus tan x. Okay. So let's put it there. Do we have any such option? No, we can't see that, but there's one step which we can do. We know that sec plus tan can be written as 1 upon sec minus tan. So if you take this minus inside, it will be 1 upon sec plus tan, and 1 upon sec plus tan can be written as sec minus tan, all right? So you can see in first option, this plus, it is plus sign in between these two terms. So if you take this plus sign inside the log here, it will be ln of 1 upon sec plus tan. I'm directly writing it sec x minus tan x because 1 upon sec plus tan is sec minus tan that we did in the previous session also. That was a form actually in which this was used, right? So sec square minus tan square is 1, and using that you can write sec minus tan into sec plus tan as 1, and that means if a into b is 1, then a and b are reciprocals of each other. So sec plus tan and sec minus tan are reciprocals of each other, all right? So this was the second problem. Now let's do this third one. So this one is a good problem. Let's see if you can solve it. It's a good problem. You can directly start applying by parts, or you can do some substitution if you want, or just figure it out. What is your first function? What is your second function? Okay, and do it. All right, so I let this is algebraic function, your 1 upon under root of 1 minus x. Let me do it. Into sine inverse. This is inverse trigonometric function. So inverse trigonometric function is the first function actually in that list I laid, right? That means you always need to differentiate inverse function. You can never integrate. Obviously, you don't know the integration of inverse function. So you'll have to differentiate it only, right? And any algebraic function, simple algebraic function, you can integrate. So yes, obviously 1 upon root x you can integrate. Integration of 1 upon root x is 2 root x, right? 2 root x integration. So let's take this first function, and this will be your second function, and apply the formula. So it will be integral of, I'm sorry. All right, so it will be sine inverse x, as it is sine inverse of root x actually, sine inverse of root x into integral of 1 upon root over 1 minus x. So you can read, it's a linear one, under root of linear. So you can apply that formula, 1 upon root x. So that is 2 root x. 1 minus x is there in place of x. But you need to divide by the coefficient of x, which is minus 1. So minus sign will appear here, right? I'm putting minus sign here. Then minus of integral of differentiation of sine inverse, which is 1 upon under root of, what is the differentiation of sine inverse x? 1 upon under root of 1 minus x square. So 1 minus square of root x, that is x, into differentiation of root x. So if you differentiate root x, that will be 1 by 2 root x, right? 1 by 2, 1 by 2 root x, all right? And integral all of this, which we have written earlier also, so plus, because of this minus will come, and 2 times of under root of 1 minus x dx, okay? So this is the whole thing, differentiation and integration. Now you can see these two terms will get cancelled, right? So cancel then these two terms and write the remaining one. So 2 under root of 1 minus x sine inverse of root x, all right? You can cancel 2 as well, and it is plus 1 upon under root of x only, so that will be 2 root x, all right? So 2 root x plus c. You can take 2 common and write the final answer after simplifying. So it will be 2 root x minus under root of 1 minus x into sine inverse of root x, all right? So that is the answer. So I hope you have got it. So which option is correct? You can see which option is correct. Root x minus under root of, so A option is correct, all right? So option A is the correct option. Now let's try another one. This is the next problem. Try it. Try it. Apply by parts. See which function is the first function and which functions to be taken as second. And apply by parts and try to figure it out which answer is correct. Are you guys solving it? If anybody is solving it, then please write the answer or let me know if you are solving. Select your first function and second function. It's a good problem actually. All right, then let me do it. I'll take, obviously, the algebraic function will be the first function. So I'll differentiate x and I'll write this function upon, as sin x upon cos cube x. Why? Because if I put cos is equal to t, I'll write the integration here, sin x upon cos cube x, all right? So this is differentiation of cos is just put minus sign and minus sign. So derivative of cos is sine, so it is f dash upon f cube. So if you integrate f 1 upon t cube, then integration of 1 upon t cube is minus 1 upon 2t square, right? Minus 1 upon 2t square. So using that, you can write the answer of this is 1 upon minus is already there, 1 minus will also come, so it will become positive, and 2 t square, t means cos square, all right? So cos square x. So this will be the integration. Or you can put cos x is equal to t sin x minus sin x dx will become dt upon t cube, and then apply that formula. Finally, you are going to get this, all right? So I've written this integration here because while applying the by parts, you need to integrate this one, all right? So write the antiderivative of it separately and use it directly in the formula. So after applying, you'll get first function as it is x into integration of second, antiderivative of second, which is 1 upon 2 cos square x, all right, minus, let's keep it separate, minus integral of differentiation of first, which is 1, and integral of second, which is 1 upon 2 cos square x, all right? Do you know the integral of now 1 upon cos square x? Yes, of course. 1 upon cos square is sec square, and we know the formula of sec square, right? So it's done, finished. 1 by 2 of x into sec square x minus it is 1 by 2 of integral of sec square x dx. And integral of sec square is nothing but tan x, right? So take 1 by 2 common. It will be x sec square x minus tan x, all right, plus c. So that is your answer, all right? So I hope it is clear. Now let's move to another one. This is next example, next practice problem. Solve it, and then I'll tell you the answer. In this, you can see only one function, which is composite function. All right. So how to do it? Think about it. Okay, so then let me solve it for you. So in such questions, whenever you have only one function and you can see log, okay, log in composite in place of x. So first of all, remove this by putting this is equal to t, okay, ln x is equal to t. And it's never a problem whenever you have ln x is equal to t. Because even if its derivative is not present, no problem, you'll get e raised to x, e raised to t actually. So you'll get, you can write x is equal to e raised to t, and you can write dx is equal to e raised to t dt. Okay, so it's not a problem to have this e raised to t dt as dx. I have replaced dx by e raised to t dt, and this will become cos of t. Now you are familiar with this. We have done this problem. We have applied by parts 2 times, so I'll do it quickly. So first into integration of second, right? So always this e raised to is their second function. So cos of t into integral of e raised to t is e raised to t minus integral of differentiation of cos of t is sin t with minus sign. So it will become positive, and then e raised to t as it is dt. And then again we'll apply by parts. So it will be cos t e raised to t. All right, plus again apply by parts, so sin t into e raised to t is e raised to t minus integral of sin t, differentiation of sin t is cos t, and e raised to t is always e raised to t whether you differentiate it or integrate it, so no need to worry about it. All right, now this has become I, so it's separated, so you'll get 2i is equal to, you can take e raised to t common, and it is cos t plus sin t. So you can see how fast we can do it. So I is equal to 1 by 2 of e raised to. Now replace t. T was ln x. All right. So actually e raised to t is x. So write directly e raised to t as x. All right. So this is your x, and this is cos of ln x plus sine of ln x. All right. So this is your answer plus c, integrating constant. So see which option is correct. X, y, 2. All right, you need to write. So this you can multiply and divide by root 2. After multiplying, dividing by root 2, you need to write this as, let me write the answer. So if you multiply and divide by root 2, if you take this root 2 inside, so 1 by root 2 can be written as cos 45 sine. You can write this in terms of sine, in terms of cos, because it is answer is given in terms of cos. So you can write, let me write the final step, 1 by root 2 x into, all right. So you can write cos of 45, 1 by root 2 can be written as cos of 45, cos of ln x, and this 1 by root 2, okay, 1 by root 2 is inside, so 1 by root 2 will be here and here also. So that second 1 by root 2 in the second term will be, can be written as sine pi by 4 and sine ln x. All right, so you can see sine a cos b plus sine a sine b is cos of a minus b. You can choose anyone as a, any one angle as a, and second angle as b, doesn't matter. So cos of a minus b, so you can write ln x is written minus pi by 4. All right, like this, plus c. So now you see which option is correct, x by root 2, x by root 2, and this. So last option is correct. All right, the last option is correct. Now let's solve our last problem. In this you have only one trigonometric function. So see which method you need to apply in this. All right, try this one. This is our last problem. So in this, you can take either 1 into, sometimes you take whenever you have such functions like if you have only tan inverse x, okay, this is one example. So in this, what to do, how to start tan inverse, you can't do any substitution. Generally, you take 1 into this, all right? So if you take 1 into tan inverse, you can apply this formula. So you always integrate one. So tan inverse x into integration tan inverse x into integration of 1 is x minus differentiation of tan inverse is 1 upon 1 plus x square and integration is x, right? Now you know what to do. You can integrate this easily by multiplying, dividing by 2, right? This is ln of, so you can do it, right? So this is one of the way. But in this, if with trigonometric function, if you take 1 into trigonometric function, that will be, that will be a problem. Why? Because when it was tan inverse and after differentiating it became an algebraic function, right? You can see, so it clubbed with x. But in trigonometric function, it will never become algebraic function, it will remain trigonometric function, right? And that unnecessarily one algebraic function will also appear, x, by integrating one. So never take one with trigonometric function, all right? Then what to do? Then you should do one thing. Do you know the integration of sec? Do you know the integration of sec square? You need to integrate one such function of integration, trigonometric function, whose antiderivative is known as well as it is not, it is simple actually. So you have two options. You can take either sec or sec square. But integration of sec is ln of sec plus tan. So log function will also appear. What is the integration of sec square? It is tan x. So let's integrate sec square, all right? So if we integrate sec square, it will be tan only, no other function will appear, right? And the remaining sec, which is only one sec, sec to the power 1, can be differentiated, okay? We can differentiate sec, it will be sec into 10. And further we can simplify it, okay? So split this, whatever sec, whatever power of sec you have, write sec square separately always, sec square theta, and rest of the power of sec separately. So it has only one sec remaining. And then apply by parts. So sec square you need to integrate. So it will be your second function and this will be your first function. Both are trigonometric. So you need to decide it. Okay. You need to decide it and this is the way. So integrated first function sec theta into integration of second is sec tan theta minus differentiation of sec, which is sec theta into tan theta, and integration of first is tan theta, all right, d theta. This, take this is equal to I. So you can see now it is sec theta tan theta as it is, all right, minus what to do with tan square, right, in terms of sec, all right. So again you are going to get sec cube, all right. So that is not a problem because we can write that is equal to I now. Sec square theta minus 1 d theta, and in next step you can see it is sec theta into tan theta minus, multiply this, so it is going to be sec cube, which is I, and it will be integration of plus integration of sec theta, which is ln of sec theta plus tan theta, all right. This one done, we are done. Just need to separate I. So separate this. So 2I is equal to, or directly write I. So I is equal to 1 by 2 of sec theta into tan theta minus, plus, sorry, plus ln of sec theta plus tan theta, all right. So this is your answer, plus C, all right. So I hope it is clear. So A is the correct option, all right. A is the correct option. So thank you for watching this. We'll continue this integration by parts, some special forms of this integration by parts, right? E raised to x fx plus f dash x, which is very important for exam point of view, because that question is, I mean, that particular form is asked too many times in too many exams, okay, almost on all the exams, all right. So that is a very important form and very interesting as well, right? So we'll do it tomorrow. We'll cover all types of problems in that particular problem, and that is slightly, interesting as well as difficult as well, right? You can always create difficult problems in integration. Today's problems were very basic and simple, right? we are practicing this method. So we'll continue tomorrow. Like and subscribe this channel if you haven't done so far. Again, like my videos, use my code if you are planning to get the subscription. And as I told you, 10th September price is increasing, so do it now. Take the subscription now.